Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble code P0970, which indicates an issue with the AT clutch pressure control solenoid valve C in the Honda Accord models from 2012 to 2017. The DTC signifies that there is an open circuit or a short in the electrical system related to this specific solenoid valve, and it prevents the transmission from shifting to any gear other than first, second, or fifth gear due to a fail-safe feature designed to protect the transmission. The solenoid plays a critical role in regulating hydraulic pressure in the automatic transmission, thereby affecting gear shifts and overall performance. It's important to note that this issue is strictly electrical and not caused by any mechanical problems within the transmission itself. The code can often stem from wiring faults, bad connections, or a defective solenoid, which must be accurately diagnosed before any repair attempts are made. Data such as freeze frame and onboard snapshots should be recorded prior to starting the troubleshooting process to ensure a comprehensive overview of the issue. The final troubleshooting step involves checking the AT clutch pressure control solenoid valve C directly by measuring the resistance between the designated test points. Ensure that the solenoid connector is disconnected and that the PCM connector remains unplugged during this measurement to ensure accuracy. The specified resistance range for the solenoid should be between 4.7 to 5.9 ohms. If the measured resistance falls within this range, the solenoid is deemed operational. However, you should consider replacing the PCM if the DTC is still present after confirming solenoid functionality. Conversely, if the resistance does not meet the required specifications, this indicates that the AT clutch pressure control solenoid valve C is faulty and should be replaced. These checks are critical to ensure that the solenoid is functioning correctly, as it directly impacts the transmission's performance. After completing all necessary repairs, the final verification step is crucial to confirm the effectiveness of the troubleshooting and repair process. Start by clearing the DTC using the HDS tool once again, which allows you to reset the system for a new diagnostic check. Following this, conduct a road test or controlled driving session to check for normal transmission function. This should include shifting through all gears under various driving conditions to ensure proper operation. During this test, closely monitor the behavior of the transmission to ensure no abnormal shifting occurs. Lastly, check for the potential reoccurrence of the DTC. By taking these cautionary steps, you can validate whether the underlying problems have been successfully addressed, ensuring the vehicle operates smoothly and reliably. To prevent the emergence of DTC P0970 in the future, it is advisable to implement a regular maintenance schedule focusing on key electrical components and connections. Begin by consistently inspecting the wiring harnesses that connect to the AT clutch pressure control solenoid valve and the PCM. To ensure reliable connectivity, it is wise to clean and maintain all connectors, as moisture or oxidation can lead to poor electrical performance. Additionally, periodic testing of the solenoid can help you identify any issues early, thereby preventing more significant problems down the road. Incorporating these preventive measures into standard service routines can significantly enhance the longevity and reliability of the vehicle's transmission system. Keeping an eye on these aspects not only preserves the performance, but also contributes to overall driving safety and efficiency. In conclusion, DTC P0970 is a diagnostic trouble code that indicates an electrical issue specifically related to the AT clutch pressure control solenoid valve C in the Honda Accord models from 2012 to 2017. Throughout this presentation, we have established the primary symptoms, possible causes, and structured troubleshooting steps to accurately isolate and remedy the issue. It is vital to understand that the problem is rooted in the electrical circuit rather than mechanical faults in the transmission. Ensuring that you follow the troubleshooting process methodically is essential for effective diagnosis and repair. Finally, implementing preventive maintenance will not only help in prolonging the life of the components involved, but also enhance the overall reliability and safety of the vehicle. Being proactive in these areas can save time, money, and ensure a more enjoyable driving experience. The AT clutch pressure control solenoid C is a vital component located within the transmission assembly of the Honda Accord. Its primary role is to precisely control the hydraulic pressure that is necessary for engaging and disengaging clutches within the automatic transmission. By modulating this pressure, the solenoid influences the vehicle's ability to shift gears smoothly. In terms of location, the solenoid is situated in the secondary valve body of the transmission, making it less accessible compared to other engine components. Electrical signals from the powertrain control module, PCM, command the solenoid to open or close, ultimately affecting the gearing mechanism. If the solenoid is experiencing an open circuit or short, it can severely limit the vehicle's performance and cause erratic shifting behavior. This is crucial to diagnose accurately since the solenoid's failure or a related electrical problem leads to the DTC being stored in the system. The DTC P0970 is generally caused by issues within the electrical circuit related to the AT clutch pressure control solenoid valve C. One common issue could be an open circuit, which prevents the solenoid from receiving the necessary signals from the PCM. This disrupts its function and leads the transmission to enter a fail-safe mode, restricting it to certain gears. Another possible cause may involve poor connections between the solenoid and the PCM. These can happen due to corrosion or damage from heat cycles over time. Loose terminals can also give rise to intermittent connectivity, resulting in similar symptoms to a complete failure. Therefore, it's critical to examine the wiring harnesses and connectors associated with the solenoid. In summary, the issue could be linked explicitly to electrical faults rather than mechanical failures, which simplifies the preliminary diagnostic approach. When DTC P0970 is triggered, drivers may immediately notice that the vehicle's transmission will not shift out of first, second, or fifth gear. This is a direct result of the fail-safe mode implemented to protect the transmission from potential damage stemming from the electrical issue. Additionally, the check engine light typically illuminates on the dashboard, indicating that a problem exists within the powertrain system, which can lead to confusion about the vehicle's readiness for operation. The inability to shift gears affects not only performance, but can also have an impact on fuel efficiency. Drivers may experience a significant decrease in acceleration under normal driving conditions. Thus, understanding these symptoms helps in quickly addressing the issue, minimizing driving risk, and restoring vehicle functionality. For the first troubleshooting step, it is essential to start by ensuring that the engine is in the on mode. This is done by pressing the engine start-stop button without starting the engine. Next, the diagnostic tool known as HDS, or Honda Diagnostic System, should be used to clear the DTC from the memory. This resets the system and allows for real-time monitoring of any pending or confirmed DTCs, which are diagnostic trouble codes, after clearing. Once cleared, the next step is to check again for any pending or confirmed DTCs. If DTC P0970 reappears, it confirms a persistent failure, allowing you to proceed to Step 2 in the troubleshooting guide. If the DTC does not reappear, the issue may be intermittent, and it is recommended to inspect wiring connections closely to eliminate the possibility of a poor connection as the underlying cause. In the second step of troubleshooting, start by turning the engine off by placing it in off mode. Following this, utilize the HDS tool to short the SCS line, which is particularly useful for isolating the fault in the circuit. After this action, the next crucial step is to disconnect the PCM connector B, specifically the 51P connector. This action disengages the PCM from the circuit, facilitating a more detailed examination of the wiring. You will then proceed to check the continuity between designated test points to evaluate whether there is a short circuit in the LSC line. The test condition is crucial here. Ensure that the vehicle remains powered off. Understanding the significance of each action during this step will greatly enhance your troubleshooting efficacy. For the third troubleshooting step, begin by disconnecting the AT clutch pressure control solenoid valve C2P connector. This is a crucial step because it allows for an isolated assessment of the solenoid's functionality without interference from other components. The next task is to check for continuity between the designated test points, which will tell you whether the LSC wire, an abbreviation for the low side control wire, is shorted to body ground. This test is done in off mode, ensuring no current flows through the circuit during your measurements. If continuity is detected, it's indicative that there is a short between the LSC wire and body ground, necessitating repairs. Conversely, if no continuity exists, then the LSC wire is likely to be in good condition, suggesting that the AT clutch pressure control solenoid valve C may be faulty. This targeted approach can effectively streamline the diagnostic process. During the fourth troubleshooting step, you will again start by disconnecting the AT clutch pressure control solenoid valve C2P connector. This step ensures that you can conduct an accurate continuity test without electrical interference from other components. Once disconnected, check for continuity between the set test points. This step checks the integrity of the LSC wire, which is crucial for the proper operation of the solenoid. If continuity is found between the solenoid connector and the PCM connector B terminals, this indicates that the wire itself is in good condition. However, if there is no continuity, you will need to repair an open in the LSC wire. It's vital to identify the location of the break or fault. This structured approach aids in directly pinpointing wiring issues, streamlining your diagnostics. In the fifth troubleshooting step, the focus shifts towards checking the PG line, which stands for power ground wire, representing another critical path in the electrical configuration. Begin this step by checking continuity between test points, similar to steps before with the AT clutch pressure control solenoid valve, C2P connector, and the PCM connector B. This check will help determine if there are any open connections or wiring problems affecting the operation of the solenoid. Specifically, if continuity is lacking, you will need to repair an open in the PG wire that connects the solenoid valve C to the body ground or make repairs to a poor connection at the ground, G101. These actions are crucial for ensuring that the solenoid receives the power needed for its operation. By confirming these connections and wiring paths, you can eliminate potential faults that may be leading to the DTC. Please like and subscribe to the channel. See you next time.